Dear colleagues, can you hear me?
Yes, I hear you.
Thank you. So I welcome you on a second international workshop on computer information technologies in Industry 4.0. My name is Vasil Dozorsky and I am a secretary of this workshop. The organizers of this workshop are Pavlo Marushchak, Doctor of Science, Professor, Vice Rector of Scientific Work in Ternopil Ivan Piliy National Technical University, and Andrei Sverstyuk, Doctor of Science, Professor of Medical Information Department of Ivan Gorbachevsky Ternopil National Medical University. Let me give them the floor. So please, you're welcome. Maybe Andrei Stepanovich?
Yes, thank you very much. Good morning, dear participants of the second international workshop on computer information technologies in Industry 4.0. I sincerely welcome you to a large scientific event, the purpose of which is to highlight and discuss the current state and features of the use of the latest advances in computer information technologies. Today, such industries as automation, electronics, and medical equipment cannot develop without information technologies. This approach ensures the creation of cyber-physical systems of virtual and augmented reality, management of physical processes, creation of intelligent systems, involvement of Internet technologies. The listed industrials are defined by the concept of Industry 4.0, which is leading the trend of the fourth industrial revolution that is happening now and use the following technologies. The Internet of Things is used to organize the complex interaction of technical systems, devices, sensors, and their automated interaction with each other without human intervention, increasing the functionality of advanced high-tech industrials, technical and telemedical complex or systems. At the same time, the Internet is a medium for data exchange and provides appropriate interaction. The next example is digital ecosystems, which include various physical objects, software systems, and management tools that, thanks to information technologies, form a single whole. At the same time, a close relationship between physical and computing resources is ensured. At the same time, big data analytics is important, which includes the accumulation and processing of huge amount of data as a result of the digitalization of various signals of the physical world with the help of cloud computing and artificial intelligence technologies. The main goal of the second international workshop on CITI 2024 is to highlight and discuss the latest scientific achievements in the listed areas, which combine modern technical achievements with information technologies. Once again, I congratulate all the participants of the second international workshop on computer information technologies in Industry 4.0. I sincerely wish everyone fruitful scientific work, good health, fulfillment of dreams, quick victory, and peace in Ukraine. Thank you very much for attention. Okay.
Thank you, Andrei Stepanovich and Pavlo Rostovich. You're welcome.
Thank you. I also will be happy to invite our participants, like my colleague, Professor Sverstyuk. Dear colleagues, on behalf of organizing committee and as a general chair, I am pleased to open the second international workshop on computer information technologies in Industry 4.0, which takes place in Ukraine, Ternopil, June 12th, 14th. 2024. This workshop is organized by faculty of Applied Information Technologies and Electrical Engineering of Ternopil Ivan Paluy National Technical University. Second international workshop on computer information technologies in Industry 4.0 promote and disseminated knowledge in several topics and technologies related to computer information technologies in various areas of industry. The main goal of workshop is to bring together researchers, scientists, experts from universities, from companies, institutions, communities, agencies, associations, and associated to provide them with unique platform for exchange ideas from around of the world, as well as the latest development in the field of Internet of Things, digital ecosystems, big data analysis, complex information systems. Thank you for submitted papers, and I wish you interesting discussions, new creative ideas, and scientific inspiration. Thank you.
Thank you for research. And now I want to give the floor to the head of our program committee, Doctor of Science, Professor, great scientist, Vasyl Martiniuk, University of Bielsko-Biała, Poland. Vasyl Petrovich.
Thank you. Dear ladies and gentlemen, on behalf of the National Program Committee, it's a pleasure for me to start the second international workshop on computer information technologies in Industry 4.0, which will be held in Ternopil from June 12 to 14. The workshop is organized by Ternopil Ivan Paluy National Technical University. The workshop is focusing on the implementation and use of the latest achievements in the field of computer information technologies in various fields of industry, which is very essential in current world. Today, such fields as automation, electronics, medical devices are closely dealing with the development of the current IT technologies, the development of cyber-physical systems, of virtual and augmented reality, control of physical processes, creation of intelligence systems. The fields which are declared the main topics of CITI conference is cutting edge of current industry, and actually the coverage and discussion of the latest scientific achievements in these directions would combine modern technical achievements with information technology are the main goals for the workshop. And unfortunately, due to the workshop took the form of online presentation by invited speakers and presentation of peer-reviewed individual papers. And I'd like to send my gratitude and a lot of thanks to all of the members of program committee and particular organizational committee reviewers for organizing the reviewers process. And it allowed us to improve the quality of the works essentially. And finally, I'd like to wish all of you good health and fruitful work during the conference. And at this point, I'd like to ask the workshop moderator to continue the workshop. Thank you.
Thank you very much, Vasyl Petrovich, for your help, for your work, and for your time spent on this workshop. Thank you.
Thank you.
And now I'll want to start with a brief statistics. 73 papers were submitted to this workshop, both from universities in Ukraine and abroad. In particular, papers came from more than 50 Ukrainian universities, as well as from Algeria, China, France, India, Kyrgyzstan, Morocco, Poland, and United Kingdom. Based on the program committee review results, only 29 best papers were accepted for this workshop. And now, regarding the workshop regularities. According to the workshop program, authors are given up to 10 minutes for the presentation and discussion of each paper. During the workshop, changes are possible in accordance with the situation in Ukraine. In particular, in the case of air alarms, there will be breaks, and continuation of the workshop will be after the air alarms are over. Also, in the event of a power outage and the author's inability to present their scientific results, I'll turn on the corresponding video presentations, if they are available. And taking into account a difficult situation in Ukraine and unpredictable factors, the workshop is held over 3 days. Authors who are unable to present their papers according to the workshop program will have the opportunity to do so during the following days of the workshop. So, according to the workshop program, 16 presentations will be given today. And the first report is information and technological tools for analysis and visualization of open data in smart cities, authored by Oleg Palka, Lesa Dmitrotsa, Alexey Duda, Natalia Kononets, and Volodymyr Pasichnik. So please, our speakers here.
Dear ladies and gentlemen, in my presentation, I would like to report on information and technological tools for analysis and visualization of open data in smart cities. The materials given in this paper were developed by the authors according to the results of investigations carried out during 4 months at Ternopil-Ivan Puluy National Technical University. At present, information technology projects of smart cities are being actively implemented around the world. The use of information and communication technologies in various aspects of people's everyday life generates big data sets. The dynamic creation and updating of open data sources makes it possible to arrange the processes city residents' activities. The interaction between information technologies, social change, and political strategies creates a lot of new opportunities for the development of smart cities. IoT plays a key role in the development of smart cities. It represents interconnected devices and systems operating together in order to improve efficiency, sustainability, and quality of urban life. For example, smart home and vehicle control applications have attracted considerable attention in scientific and industrial communities. Open data generated by various IoT sensors play an important role in the development of smart city. Integration and processing of data make it possible to create, implement, and develop smart services with high social and economic characteristics. Open data sets and collections in smart cities are produced in the urban digital environment. It is formed on the basis of physical infrastructure, structures, building, and social factors, citizens, institutions and organizations, educational and cultural institutions, authorities. Implementation of innovative digital services in smart cities requires consolidation of open data sets. After analytical processing of open data, it is reasonable to develop information dashboards for their visualization. The next slide shows the sets of open data in Ternopil city. We will develop information and technological tools for consolidation, analytical processing, and visualization of open data for smart city services and facilities. At the moment, due to the martial law, open data access to data is significantly limited in Ukraine. However, certain data sets that do not disclose critical information are published. In particular, there are a number of groups of open data sets on Ternopil Open Data portal. 16 data sets are published and updated monthly. Microsoft Power BI information and technological tools were used to process open data sets. They were used to convert them into formats suitable for analytical processing and visualization. The next slide shows the dashboard for tracking citizens' requests to Municipal Enterprise Ternopil-Vodokanal. The information and technological tool for tracking citizens' requests to Municipal Enterprise Ternopil-Vodokanal was developed in the form of the information dashboard. Data from 2023 are consolidated and processed in it. The developed information dashboard carries out analytical processing of open data regarding to requests to municipal enterprise Ternopil-Vodokanal. As a result, recommendations regarding the identified problematic locations of the water supply network are formed. Decision-making support functions are implemented on the basis of machine learning. The interface of the developed information dashboard for consolidation, analytical processing, and visualization of open data sets of the request to municipal enterprise Ternopil-Vodokanal is presented on the next slide. Due to the developed information dashboard for tracking citizens' requests, more than 6,600 of data sets of the request of city residents for 2023 are consolidated in municipal enterprise Ternopil-Vodokanal. The next slide shows information dashboard for monitoring the processes of emergency and regular works of city infrastructure maintenance. The information and technological tool has been developed in the form of the information dashboard consolidating and processing data for the period from 2021 to 2023. The availability of data sets and collections makes it possible for the citizens to monitor the processes of emergency and regular work of the city infrastructure maintenance due to the information dashboard, which is presented on the next slide. From the data collections published in Ternopil Open Data Portal, 1169 sets regarding the permissions for city infrastructure facilities maintenance are consolidated for the period from 2021 to 2023. After receiving the permissions, most of the works are completed within a few days. The developed information dashboard for monitoring the processes of emergency and regular maintenance work is beneficial for city administration employees while developing and implementing KPIs. In particular, due to it is possible to track the duration of work and, in case violation of the terms of execution, coordinate promptly further actions with the executors. According to the results of the investigation, we can confirm that, first, urban data sets are dynamic and require innovative solutions to analyze and display them. Second, information and technological tools are used for consolidation, analytical processing, and data visualization in the form of information dashboards. Third, rapid response of the employees of municipal enterprises and representatives of local authorities to the requests and needs of residents while implementing information dashboards make it possible to improve the city's performance indicators and to assess the smartness indicators in general. Thank you for your attention.
Thank you very much. Dear colleagues, maybe you'll have some questions.
Hi everyone, my name is Irina Bibic, Department of Computer Integrity Technologies. So I have some questions. For example, tell me please, what is the importance of information dashboards of the development of smart cities? Thanks.
Thank you for your question. An information dashboard in a smart city serves as a tool to display general information about the city in a single view, helping citizens to monitor and analyze its ongoing activities. This information gives an overall picture of the current state of all the city system and allow to the analysis and identification of recurring trends and behavior over time. This in turn enables the prediction of future incidents and the formulation of proactive solutions.
Okay, thank you very much for your great answer. And the next, could you please provide a more detailed description of capabilities of Microsoft Power BI?
Thank you for your question. Microsoft Power BI makes it possible to create cross-platform interactive information dashboards that can be accessed locally via web interfaces or through mobile applications. Data processing is carried out by Power Query software and algorithmic tools for consolidating heterogeneous and different types of data. They provide the opportunity to set up automated updating of information sets from dynamic open data sources on a scheduled basis.
Okay, thank you very much for your answer.
Thank you very much. Dear colleagues, maybe any other questions? No
Good morning.
questions. Yes, please.
I want to ask some questions for you. Please, why did you choose neutral networks for
Can you please repeat?
Vadim Koval, do you have a question? No question, maybe some technical problems. So let's move to the next report. The next report is the use of neural networks for modeling the thermophysical characteristics of epoxy composites treated with electric spark water hammer. Authored by Petro Stupляк, Vasil Martinyuk, Oleg Tutorsko, Danilo Stupляк, and Irina Didic. Please.
Була така щось палацу. Розумієш? Ну, чи мені десь не відповідали, так? Ні, вони є вже тут, розумієш? Але чи, ну, тоді було балакати. Не знаю. Ні, просто з такої ситуації.
Okay, tell me please, can you hear me well?
Yes, we are, please.
Okay, so presentation on topic, the use of neural networks for modeling the thermophysical characteristic of epoxy composites treated with electric spark water hammer presented to your attention. I cannot. Can you see the next slide or no? Polymer composites material are used in various industries: mechanical engineering, construction, and aviation. Composite materials are increasingly used in critical elements of aircraft. So the modern technology operating polymer composites, including epoxy composites, is aimed at studying methods of controlled divided change in material structure parameters. The latter, in most cases, determine physical mechanics and operation characteristics of epoxy composites. Methods of experimental studies are often complicated and expensive. In particular, with a large amount of experimental data, it is advisable to use machine learning methods because they need to be generalized and that is to find the dependence that the most accurately approximates them. So machine learning methods, which instead of being programmed, are capable of analyzing data and learning from them. The aim of this investigation is to study the materials of different temperatures of epoxy composites filled with DAC1, aluminum oxide, chromium oxide, and carbon black using neural networks. The parameters of the thermal coefficient linear expansion of polymers should be predicted by algorithm of supervised learning, that is, neural networks. So, what is the neural networks? Neural networks are the family of models built using the principle of organization and functioning of biological neural network, networks of nerve cells of living organisms. So neural network is one of the machine learning algorithms where the computer learns to solve different problems by analyzing examples of training set. They can also predict new data that the system has not seen. So here you can see the biological neural networks and the some neural networks. Yes, here you can see the axon from a neuron, some synapse, the treat and the cell body, activation function, and output function. So neural networks are the collection of neurons connected to each other. In order to create the neural network to solve a specific problems, it is necessary to choose how to connect neurons and the parameters of the connecting weights. The structure of neural networks are closely related to the use of learning algorithm. Yes, here you can see the single-layer feed-forward networks, the multi-layer feed-forward networks, and recurrent networks. So there are three ways for neural network learning: supervised, unsupervised, and mixed. So in this case, supervised learning, teacher participation is the knowledge presented in form of input-output couple. So the thermal coefficient of linear expansion is predicted by machine learning methods according to the experimental data obtained in paper by Bucetto. Here we use the output parameter for the thermal coefficient linear expansion. For example, linear concentration and temperature were considered as input parameters. During learning, the data set was divided into two unequal parts, a learning and test sample. For example, 18% of sample are randomly selected for the training sample from all experimental data, and 20% are left to assess the quality of prediction. Here you can see the dependence of the experimental data of the thermal coefficient of linear expansion on the predicted one obtained by neural networks method are shown in this figure. So in first figure, you can see the composite field with DAC1, and the next, you can see the composite fillet by aluminum oxide. So here you can see the chromium oxide field composite, and here a composite field with gas suit. The next slide, you can see the dependencies of the predicted thermal coefficient of linear expansion and the filler concentration in the composite, and temperature are shown in this figure. Yes, the temperature dependence of the thermal coefficient of linear expansion field with DAC1, this is the figure A, and filled by aluminum oxide B. Fillet with chromium oxide C, and with carbon back D. So to analyze data, a statistical graph is a form of residuals diagram is often used. It was found that the residuals has normal distribution. So here you can see the distribution for DAC1, here aluminum oxide, here you can see chromium oxide and carbon black. For example, neural networks parameters give us some information. Here you can see the name of network. You can see the 2 neurons in input layer, 10 neurons in hidden layer, and 1 output layer, neurons in output layer. Algorithm of learning, error function, function of hidden activation, function of output activation. So in this study, the last function was chosen as the mean squared error. And conclusion, you know that in general, method selection and data set are important to obtain good prediction results. Also, method of supervised learning usually show better results than the methods of unsupervised learning. So here you can see the prediction error of the neural networks in the test sample of AVI epoxy polymers filled with DAC1, aluminum oxide, chromium oxide, and carbon black. So you see that the results are good in agreement with the experimental ones. So thank you very much for your attention.
Thank you, Irina. And dear colleagues, maybe you have some questions. Please ask.
Good morning, please, what indicates the consistency of predicated and experimental data?
Okay, so if we come back to our slide, yes, for example, here. It is important that the point in the first coordinate angle, which indicates the consistency of the predicted and experimental data. This point should be nearest to each other, yes? For you see that the first coordinate angle give us the good, for example, results accuracy, yes, of our experimental and predicted data.
Thank you. And the last, which parameters determine the predicting accuracy of neural network?
Okay, so we have some, for example, very important parameters. If we come back to our slide, you see that the important parameters depend of, for example, when we choose our network. It depends how many neurons we choose in the hidden layer, what algorithm of learning we choose, error function on hidden activation, yes, because when you obtain some signals, this function of hidden activation give us a good result. And very important, the function of output activation. These parameters have important information of our results and accuracy.
Okay, thank you.
Thank you. Maybe any other questions? Okay, thank you, Irina. And let's move to the next report. Estimation of accuracy, stiffness, and stability of shell structures of mirror antenna using computer simulation, authored by Andriy Sverstyuk, Mykola Stashky, Andriy Remes, Mykola Poshevak, and Volodymyr Makohan. Please, are speakers present here?
Yes, I'm here. I'm ready.
Okay, so please.
1 minute. Okay. Can you see my presentation?
Yes, we can.
Okay. So, dear participants of the conference, let me introduce my presentation, my report. Referring to the evaluation of the accuracy, stiffness, and stability of the shell structure of mirrorless antenna using simulation model. The loads on the involved elements of mirror antennas determine the strength and durability, depending on the purpose and method of operation of the device of which the antenna is an integral part. The loads can be of different types and are determined mainly by mechanical, stress, and temperature conditions. The shell elements of the structure of the remote sensing equipment are made in the form of shells of complex shape. When assessing the strength and performance of shell structure, it's necessary to consider various tests. The test of stress strain state stability and bearing capacity in static and dynamic simulation. The theory of shell has been developed with fully and present in various works of scientists, the source of its development is technical specification. The main achievements of the theory are reflected in many works, of which we will highlight manufacturing, production, and design, which were carried out by scientists from Ukraine and brain cultures, as reflected in work.
These papers describe the main achievements of the theory of shells, presented the general equation of the theory and methods for solving them, and consider many special problems. A satellite antenna is an antenna used to receive or transmit radio signals between ground stations and artificial Earth satellites. Mirror antennas are the most common class of satellite dishes. They're used in different bands from decimeter waves to Q-band and on different types of stations, from individual TV reception systems to space communication centers. Mirrored antennas are antennas in which the field in the opening is formed as a result of the reflection of an electromagnetic wave from the metal surface of a speech reflector mirror. So you can see the geometrical characteristic of the paraboloid of rotation. The offset antenna is the most common and in individual satellite reception. An offset antenna is an elliptical paraboloid in the cross section of an eclipse. The focus of such a segment is located below the geometric center of the antenna, which eliminates shadowing of the antenna, used area by the irradiator, and its support, which increases its efficiency with the same mirror area as an asymmetric antenna. Typically, offset antenna are used to receive Q-band signal in linear and circular polarization. However, it's also possible to receive a signal in the T-band as well as combined signal. So you can see the value of the offset antenna. Formation of shells by electric spraying and application of composite material. The formation of mirror antennas consists of several stages. The first stage is the formation of a two-dimensional mesh and the fixing of nodes by electric arc spraying with aluminum. Now we can see electric arc spraying method for mesh material. The mesh blank 3 is placed on the working surface of the punch and its edges are split with a contour. A parameter ring 5 is placed on the surface of the mesh blank along the contour of the punch and moved, for example, with elastic clamp 6 in direction that ensures that the blank is primed on the working surface of the punch. As the manufacturer of large size shells, one or more additional mesh blanks with larger meshes and made of wire or larger diameter are applied to the third blank with small meshes. The second stage after spraying on the punch is to obtain a surface with a high temperature and apply a composite material such as polystyrene. So result of wine float modeling. The normal wine float Pascal can be determined in the first approximation by the formula. According to the result of modeling of the flow around a parabolic antenna, which a diameter of 1.5 meter made of a 3 millimeter thick aluminum sheet by an incoming air flow with a speed of 20 meters per second, a value of the normal wine float of 440 Pascal was obtained, which corresponds to the flow coefficient K 0.9. Wine float modeling. A solid state model of a reinforced composite parabolic antenna consisting of the following elements was created: aluminum, spraying, reinforcing mesh, protective plastic, ring of the locking mechanism. Graphical representation of reinforced composite material. This is a 1.5 meter diameter antenna modeling consisting of mesh material that has been electrodeposited and a composite layer overlaid on it. To evaluate the stiffness strength characteristic of antenna of solid and reinforced structure, we calculated the stress strain state under the action of wine float and gravity. So we can see the safety factor for a 3 millimeter thick aluminum antenna, and we can see the safety factor for a reinforced composite parabolic antenna. The occurrence flow results on the estimation of accuracy, stiffness, and stability of shell structure of mirror antennas by means of simulation modeling as the basis for their use in cyber physical observatory systems. we can see the deformation of antenna made of a solid sheet of aluminum under Weinhold scale of deformation display is 2001. Okay, so my conclusion, in the course of the work, the method of manufacturing antenna system and manufacturing reflective filters based on new technological design are considered. The process of formation of shells from mesh material then can be used for the manufacture of axisymmetric and non-axisymmetric reflectors for individual elements of mirror antennas investigated. This is because the formation of this material consists of several stages. The first stage is the formation of the two-dimensional mesh and fixing of the nose by electric spraying with aluminum. The second stage, after sputtering on the punch, is to obtain a surface with a high temperature and apply a composite material such as polystyrene. The calculation allows us to establish and it's presented graphically that despite the loss of stiffness of the reinforced structural antenna compared to the antenna made of a solid sheet of aluminum, the safety factor of the reinforced structural antenna is 0.8 and remains sufficient, although it's significantly less than that of the antenna made of a solid sheet of aluminum. So thank you for attention.
Thank you. Your work is very interesting and very important, especially in time of war in Ukraine. But dear colleagues, maybe you'll have some questions.
Well, I have a question. Can I ask?
You're welcome, please.
Yeah, please, first of all, the sound was very bad. I'm sorry, but I can't hear. I only read the information from the slides, but everything is clear. Okay. My question is such. What software and calculation methods you use during your modeling, for your modeling, okay?
Okay, let me answer on the question. It's an interesting question. We use SolidWorks software and the finite element method with the application of computational fluid dynamics option.
Thank you. And one little remark concerning your slides. Please change the Russian language, please. It's important.
Thank you. Thank you. And next report is estimation. Neural network methods for identifying potential defects in complex dynamic objects. Authored by Victoria Vysotska, Vasily Litvin, Sergey Vladov, Ruslan Yakovlev, and Yevgen Vulkanin.
Hello, my name is Sergey Vladov. Do you see my presentation?
Yes, we are, please.
Yes, I'm start.
Yes, please start.
Thank you. Good day. With your permission, I present a work, Neural Network Method for Identifying Potential Defects in Complex Dynamic Objects. The use of neural network is increasingly common for predicting and identifying potential defects in various systems and processes, thanks to their ability to analyze data and uncover hidden patterns. These mathematical models mimic the human brain, processing input data through interconnected neurons to generate outputs, and are applied in tasks such as time series analysis, image processing, and text analysis. This work is to develop a neural network methods to enhance quality control and system reliability by detecting anomalies and predicting failures based on historical data. The neural network methods for identifying potential defects based on prediction results is a powerful tool for enhancing quality control efficiency and ensuring system reliability by automating anomaly detection and failure prediction. This research area expands diagnostic model capabilities and leverages artificial intelligence adaptability to improve defect detection, classification, and prognosis, thus reducing maintenance costs and improving production processes. The developed method involves using historical data of initial indicators to create a time series prediction model trained exclusively on normal operation data without breakdowns or anomalies. By predicting expanded normal values, the model can identify anomalous behavior and signal potential defects when actual values deviate from predictions. For normal system behavior, initial indicator data is collected and presented a time series of actual values with the proposed shift from a secure to secure GRNN model to a deep learning model based on the transformer architecture to better handle data sequences and long-term dependence. The proposed model has the following architecture: encoder, decoder, positional encoding, and attentional mechanism. Transformer model successfully implemented as graph neural network, excel in training or large data sets and handling sequences of any length, making them invaluable in artificial intelligence research and development. Graph neural network offer unique advantages over other neural network, including the ability to consider data structure, adapt to various graph forms, model complex dependencies, and efficiency train on graphs, leading to their use in the proposed methods. The graph neural network training algorithm you see in the work. To assess the performance of the proposed defect identification method, a computational experiment was conducted using the helicopter turboshaft engine, SAMIS CITI-2024, across various helicopter modifications. Initially, a training sample was created and pre-processed computing parameters recorded on board the helicopter, such as rotor speeds, gas temperature, flight altitude, temperature, pressure, etc. With data homogeneity and representatives confirmed through statistical tests and cluster analysis. During the training of the graph neural network, the proposed algorithm demonstrated dependencies of accuracy, recall, and loss of the number of iterations, with the blue curve representing the training and the orange curve representing the validation set. The results show the accuracy nearly research 1, recall remains constant at 1, and loss does not exceed 0.025, indicating high training efficiency and the model's ability to accurately generalize to new data. A left top figure shows the results of identifying potential defect based on long-term prediction of the gas temperature parameter in the CITI-2024 turboshaft engine. Prediction at time 94.65 hours reveal a 4% decrease in gas temperature at time 96.2 hours and a further 3% decrease at time 99.3 hours, totaling a 7% drop, indicating possibly combustion chamber malfunctions such as crack of burnout, as shown by the burst in other figures. This finding confirmed prior research and underscore the practical significance of using long-term gas temperature prediction to enhance the safety and reliability of helicopter turboshaft engines. At the comparative experiment, the effectiveness of the proposed method was assessed, which consisted of conducting a comparative analysis of the accuracy of classical and neural network models for identifying potential defects, the results of which are given in this table, which display the results of calculating the probability of errors of first and second types when identifying defects in the compressor, combustion chamber, and compressor turbine. A complete comparative analysis is presented in the work. The conclusions are presented in this slide. Thanks for attention.
Thank you very much. Dear colleagues, maybe some questions. No questions. So maybe I'll ask you, I'm sorry, are the practical implementations of your results?
The practical implementation for is future research, but did not make practical results in war because aviation does not fly at now time. Sorry, but yes. I propose the experimental equations in some aviation industry, but this research was implemented in future when the war were finished. I'm sorry. Thank you.
Thank you very much. I understand. Thank you. And dear colleagues, the authors of one paper asked to report their work sooner. If I'm not mistaken, it's work number 13. Generative AI and its implementation impact on labor productivity and the global economy, authored by Mikhailo Rokosh, Mykola Primak, and Natalia Stadnik. So if you don't mind, let's listen this paper now. Okay? So please, I saw Mykola Rokosh is present.
Yes, thank you. Hello, everyone.
Yes, hello. So please, you're welcome.
Thank you. Dear colleagues, I'm excited to present our report on generative AI and its impact on labor productivity and the global economy. Today, we are at a pivotal point in the evolution of the artificial intelligence technology. Generative AI, a field that encompasses algorithms capable of generating new content, is transforming industries and reshaping the economic landscape. This study explores the implications of these advancements on labor productivity and the global economy. But to better understand generative AI, it's useful to see how it fits within the broader AI landscape. Artificial intelligence, on top, is a field of study that enables computers and machines to simulate humans' intelligence and problem-solving capabilities. Machine learning is a core subset of AI and an approach for developing smart machines and learning from data. Deep learning is one of such approaches. It's a subset of machine learning methods that uses artificial neural networks to mimic the learning process of the human brain. And finally, generative AI uses neural networks to generate data similar to the data it was trained on. It could be text, it could be images, music, etc. Many companies such as Netflix, Amazon, JP Morgan, and Tesla have already incorporated generative AI to secure competitive advantage. It is imperative for other enterprises to integrate and regulate this technology to stay competitive. And failure to adapt promptly may result in these companies falling behind in a rapidly evolving market. Now, let's explore key milestones in the generative AI timeline, focusing on significant developments. We start with Alan Turing and his groundbreaking research in the 50s that laid the theoretical foundations for artificial intelligence. Moving on, we see the creation of ELIZA in the mid-60s, one of the first chatbots that demonstrated the potential of machine-driven conversation. Fast forward to 1997, when IBM's Deep Blue became famous for defeating a world chess champion, Garry Kasparov. In 2011, IBM introduced Watson, which further showcased AI's abilities in natural language processing. The evolution of generative AI accelerated with the introduction of OpenAI's GPT models, starting with GPT-1 in 2018, followed by the more refined GPT-2 in 2019 and GPT-3 in 2020. DALL-E, which was introduced in 2021, pushed the boundaries by generating creative images from textual descriptions. And the following year, ChatGPT was introduced, enhancing the interactive conversation capabilities with AI and bringing artificial intelligence into the mainstream. More recently, in 2023, Adobe Firefly and Microsoft Wall-E were introduced, both expanding generative AI applications into creative and audio fields. And now in 2024, GPT-4 and GPT-4o continue to redefine the limits of language models in generating human-like text. Each of these milestones not only marks significant technology achievements, but also sets the stage for future advancements in generative AI. According to McKinsey's research, generative AI could add up to $7.9 trillion a year to the global GDP, as detailed in this figure number 3. This is part of a broader AI economic impact estimated between $17.1 and $25.6 trillion. Other AI technologies like advanced analytics, traditional machine learning, and deep learning could contribute as much as $17.7 trillion, underscoring the value of various AI implementations. Now, according to additional research by McKinsey, generative AI is expected to significantly affect knowledge work, especially in decision-making and collaboration, areas previously seen as least automatable. The estimated potential for automating the application of expertise has increased by 34 percentage points. Furthermore, the possibility of automating management and talent development rose from 16% in 2017 to 49% in 2023. In a study by Workera, participants evaluated the impact of using generative AI as an input source or copilot across 10 different activities, including language translation, documentation generation, text analysis, drafting emails, exploring our algorithms, code generation, simple data analysis, data pre-processing, idea generation, and code debugging assistance. Respondents noted that tasks taking 10 hours manually could be reduced to 5 or 6 hours with generative AI. The survey indicated a productivity increase of over 150% when using generative AI, and text-heavy tasks such as language translation, text analysis, documentation generation, and email drafting showed the most significant productivity gains. For these tasks, participants who used generative AI reported an average productivity increase of 168%, assuming these tasks would have taken 10 hours without AI assistance. But nevertheless, integrating generative AI comes with its challenges. Concerns like privacy, bias, accountability, and intellectual property rights present significant obstacles that require diligent management and regulation. As we conclude this presentation, let's summarize the current state of generative AI and its effect on work productivity and the global economy. We are currently witnessing a generative AI race in which leading companies are driving significant investments, paving the way for future advancements. Generative AI is revolutionizing business productivity, with economists predicting a potential 1.5% annual productivity growth in the US over the next decade, and a global GDP contribution of up to $7.9 trillion annually. However, as mentioned before, this technology poses challenges related to privacy, bias, accountability, and intellectual property rights, which require careful management to ensure balanced and sustainable development. Thank you for your time.
Thank you, dear colleagues. Maybe any questions? Okay, no questions. Thank you. Thank you very much for your report. And the next report is Computer System for Energy Distribution in Conditions of Electricity Shortage Using Artificial Intelligence, authored by Andriy Voloshchuk, Diana Velechko, Galina Osukhivska, and Andrei Palomar. So, dear colleagues.
Hear me?
You're welcome, please.
My presentation is, do you see my presentation?
We can see it.
Okay, thank you. Good day, everyone.
I'm sorry, we can't see your presentation, please.
We can't see. Oh my God.
Maybe share your screen.
Yep, I'll try my one again.
Oh, yes, we can see it.
Okay, good.
So please.
Good day, everyone. My name is Andriy Voloshchuk, and I'm delighted to present our paper titled Computer System for Energy Distribution in Conditions of Electricity Shortage Using Artificial Intelligence. This work is a collaboration between Andriy Voloshchuk, Diana Velechko, Galina Osukhivska, and Andrei Palomar. Nowadays, electricity shortage or backups or blackout can occur due to various situations. These circumstances include the weather conditions, accidents, or any other unforeseen events. A prime example is Russia's missile attacks on Ukrainian civil infrastructure. One of them was in November 2022, caused a massive blackout in Ukrainian power grid. Its result is electricity shortage for the Ukrainian civil population and infrastructure. To improve the situation, sought redistribution of resources and allow access to electricity for all units. Electricity availability schedule were introduced, but such schedules were being developed over a long time period. They did not always ensure an even distribution of electricity among consumers, and did not effectively take into account changes in its volumes. To respond to such challenges more quickly, and it's advisable to use all of the capabilities of modern technologies, particularly artificial intelligence, and implement intelligent energy accounting system. The study is aimed at identifying effective strategies for utilizing artificial intelligence for automated development of electricity management algorithm in situation of energy crisis or on resource constraints. The state is using artificial intelligence in suitable energy, including renewable energy and energy efficiency, described by a number of the scientific works. We have studied many of the articles by the other authors that have been involved in predict short or even medium term electricity consumption, and even using a genetic algorithm to intelligently control efficiency and optimize power system. But they not focused on power outage schedules, so we are more detailed onto this. To fulfill the data collections of the research, the proposal of utilizing the framework of computerized energy enterprise system, adopting the framework of a computerized energy enterprise system rooted in the Internet of the Things concept is advocated. Generally, intelligent system comprised by smart meters, mobile modems, enterprise routers, switches, etc. For building this system, we use the Cisco best practices. Security best practices. It's also important to protect the data which the operator later use in the system. The old managements are controlled by an automated workstation for the electrical system. It is essentially a computer-based tool that enables efficient management and optimize the electrical power system. For secure and dependable communication, smart networks employ various additional technologies. By integration, these technologies, smart network can surmount communication obstacles and establish a more efficient and secure energy management system for energy distribution in conditions of electricity shortage using artificial intelligence. For the optimal and fast distribution and energy resource between consumers, it is advisable to use the method of the artificial intelligence to search for the most efficient combination of electricity consumption zones at a given time with limited resources. It's proposed to use a genetic algorithm. This context of genetic algorithm can be used to build a schedule of the electricity availability in these zones, which helps describes energy resources quickly, more efficiently, and evenly. The following formula is proposed as a fitness function. This way, genetic algorithm has the following presentation. Each gen of the chromosomes represents a zone. Each chromosomes is a list of the zones to powered simultaneously. Each gen has its own value and the weight. In our case, a value is the number of the entities that gain access to electricity in the zone. The weight is the amount of the electricity power needed to electricity the zone. As the amount of the electricity power is limited in case of energy shortage, and this limit can change at any time, it's the most important resource to consider as the constraint for the fitness function. In the second figure, we could see how the algorithm works for a few epochs, while the important values are changed in a way of presented in the figure to provide all regions with the electricity without giving preference to just some one of them. The best individuals from all epochs are saved as a schedule of electricity availability. These selections then evaluated for fitness based on the total importance of included region using tournament selection technique of to create a new generation through crossover. That's like a combination part of the chromosomes, and mutation, that's randomly altering part of the chromosome. Over multiple generations, the algorithm evolves towards an optimal set of the region that maximize total importance within the available electric power constraint. In this slide, we could see how much one of the 11 region could use during the day. The information what we collect is by hour, by each hours. All information we use from the open source data set from kaggle.com as for security best practices, security reason of Ukraine, so we couldn't take our any information. But we visualize this information by the Datadog monitoring. We implement the CSV file and export to Datadog, so we could create tables, graphs, and other of the default metrics. The EDH should be only part of the system software. It should be used in the cycle outlined. Firstly, it is important to understand that the schedule is defined into certain time period. We use like a 2 hour. It could be more, it could be less, whenever you want. Genetic algorithm should be run for each period separately. The regions are already defined as well as the number of entities affected to average amount of electricity power needed to further the region and the power limit. Knowing how much electricity is needed to meet the needs of all regions has important benefits. Having the data will allow you to plan some maintenance and rebuild some communications nodes without inconveniencing consumers. This can solve a lot of the problems, increase performance, and provide a lot of the benefits. The schedules of electricity availability using the proposed algorithm for 11 regions with the condition limit 70,000 megawatt, which shown the figure for this limit we just take for the test. We could set any another of the value. Conclusions. The proposed computer system was designed for energy distribution in conditions of electricity shortage using artificial intelligence. The integration of AI into energy accounting system presents concrete advantage of improving the data accuracy, minimizing manual errors, and boosting overall system performance. AI-powered solutions facilitate efficient energy distribution, cost reduction, and swift response to power shortages. The proposed genetic algorithm provides a streamlined approach to distributing energy resource, ensuring equitable distribution and dependable energy supply. Understanding regional electricity needs leads to better supply planning and heightened system reliability, and fosters economical and environmental efficiency in the energy industry. Ultimately, AI-driven solutions play a pivotal role of tackling challenges and optimizing energy management during crisis and the resource limitation. This computer system may not be used not only in Ukraine, but in any of the country region where a power outage or shortage may appear due to several weather conditions or any other unpredictable events. Thank you for the attention.
Thank you for your report. Dear colleagues, any questions, please?
Good day. I have a question.
Please.
Can you hear me?
Yes, you can.
Yes. Your work is very interesting. Can you please tell me what are the benefits of using your architecture in general?
Can you repeat, please? Because it looks some.
What are the benefits of using your architecture?
Thank you for the question. Consequently, our system is quite easy to maintain, and the time they are quite variable in this of the various data transmissions and the precision device. The system continuous monitoring of the power and consumption pattern with various electrical devices in substation. It also have the ability to transfer our system our core system to the cloud services. Also, the other network device, they are could be introduced in any of the other systems. They have a lot of the algorithm how to work with other devices. It's not could be not only maybe the Cisco or the Link. You could create the lowest version of your system, or maybe more greater and use the enterprise solutions. So it's easy to maintain, to repeat, to fix any of the issue which appear during the work day.
Pretty impressive. And one more question. How does changing of the limit of the amount of available electricity affect the algorithm?
When the changing of the limits of the amount of electricity, the initial generation of chromosomes may not to meet a new restrictions. As a result, the amount and distribution of the energy in the original chromosomes may not to be adjusted to meet the new constraints. So we have the proposal to run the algorithm automatically if there sharp increase or a decrease amount of available electricity. So let's imagine our architecture collect the data. So our system, our automated system, see these values during the real-time data. So if the something change, we have more electricity or the less, our algorithm should be triggered to run again and build a new schedule based on the real-time data of electricity availability in the system.
Okay. And please clarify, can we prioritize power supply in different regions or zones?
Yes, actually we could. This fitness function add for us availability to add other values. We could call it points. What is mean points? The operator enters the new data manually. That's presented. I would say that's like amount of the critical infrastructure in the zone. If the zone have like water system for the supply of the settlements, the zone have a lot of the hospitals, kindergarten, school, the operator should set maybe plus 10 points for this zone. So, and in the next work of the algorithm, this region will have the higher value, and this region will be the first in the priority to receive the electricity. In the future, building the schedule, it will differ from when all regions or zones they have at the same priority level. So this region will have energy supply more than others, because that's have a lot of critical infrastructure or something else. It depends what operator export to the system.
Okay, thanks a lot.
Thank you.
Thank you. Any other questions? Okay, so let's continue. And next, our report is analyzing a specific of scalability laws for proper modeling of a system's source output, authored by Volodymyr Kukharsky, Dmitro Mikhalik, and Yuri Human. Please, are speakers present here?
Can you hear me?
Yes, you can.
Okay, good. Hello, dear committee, ladies and gentlemen. My name is Volodymyr Kukharsky, and today I will present my current research work analyzing specifics of scalability laws for proper modeling of a system's throughput. In today's world, there are a vast number of artificial systems designed to make our lives easier, more efficient, more safe, more entertaining, etc. Most of them are designed with performance in mind, to meet the constantly growing demands of their users. The ability of a particular system to handle a growing amount of work or its potential to accommodate growth defines scalability. Scalability is crucial in system design for a few reasons. First reason, growth handling. A properly scalable product should handle the increasing number of users. Second reason, improved performance. A properly scalable product should degrade performance more gradually. Third reason, optimized costs. A properly scalable product should save business investment in hardware to operate according to the law. Unfortunately, in terms of combining computational power, 1 + 1 doesn't equal 2. It could be some sort of cost-effective for batch work, but this combination was not effective for online transaction processing and other real-time computations. Jean M. Dahl made an early attempt to quantify the speedup factor, a number that shows how much additional performance a system will get by adding more computational units to that system to battle the increasing load. Here you can see the formulation of the law, where S is an actual speedup factor and P is a fraction which represents the parallelized portion of the work, and N is a number of computation units. Here in the slide, you can see how the amount of parallel work can be productive for a particular workload. Does this function has a limit? Yes, it does. It has its physical speed up limit and it's bound on the upper side to the fraction of 1/1 minus p. What can you see here? If we increase number of computational units infinitely and have only, for example, 5% of serial work, we will be limited on the upper side to the speed up factor of 20 because of that equation. So Neil Gunter proposed a slightly different approach to scalability quantification. His model not only uses the serial penalty, but also introduces a coherence or crosstalk penalty, which results in delays for data to become consistent during the execution of multiprocessor environments. How significant role does crosstalk delay have? It plays very significant role in the system's throughput because even a small fraction of that value can degrade your overall performance very significantly. As you can see, if we increase the number of total computational units to 128, we could achieve only at possible 9 the most effective speed up factor for this chart, and then we will see the gradual downscale of our effort. Another approach was proposed by Dr. John Gustafson to overcome the pessimistic results of Amdahl's law speedup dependence from a serial delay. Instead of fixing the parallelizable part of the workload, it fixes the running time. In other words, it answers the following questions. How much the execution time would this problem have taken if it ran on a serial processor instead of multi-core processor system? So in here you can see in the top corner the totally sequential execution where the in blue is a serial fraction, and in pink you will see a parallel fraction which runs sequentially. And in the bottom side you can see the same execution, but on a parallel workload where every parallel fraction of the work is executed independently and simultaneously. Conclusion, all described laws have a potential for scalability quantification. Amdahl's law provides a straightforward to estimate the maximum achievable throughput by considering the proportional to the workload that can be parallelized, but completely ignores parallel crosstalk, which is inevitable in modern applications. Gustafson's law recognizes the potential adjusting the problem size to fully utilize the additional resources, which can lead to a higher system throughput in parallel environments. Universal scalability law accounts for saturation effects that may occur as a system resources are increased, providing insights into the maximum achievable throughput, but the diminishing returns the diminishing returns of adding more resources, more practical than the first two, but has a cost of additional complexity and more experienced researchers when determining the coefficients for an actual system. Thank you for your attention. This is all.
Thank you for your report. Dear colleagues, maybe you'll have some questions. Okay, so thank you once more. And next report is a development of an algorithm for identification of damage types of the surface of sheet metal, authored by Yuri Polanitsky, Yaroslav Litvinenko, Abdullah Menou, Grigory Shemchuk, and Andriy Dubchak. Are speakers present?
Can you
Yes,
see?
you are.
Can you see my presentation and
Yes, we
slides
are,
scrolling?
please. Yes, all is
Okay.
good. Please make your report.
Okay, dear community, I would like to present you our research on the development of an algorithm for identification of damage types on the surface of the sheet metal. One of the important elements of modern metallurgical production is quality control of raw metal. Electron microscopes are widely used in nanotechnology and material science for examining surfaces and at high resolution. The morphology of scratches on surface plays a crucial role in determining mechanical properties and wear resistance. Therefore, accurate identification and characterization of scratch types are essential for improving product durability and reliability. Detection of metal surface defects traditionally is implemented taking into account machine vision. However, complex scratch shapes and wiring orientation pose challenges due to data collection condition variations. Instead of solely relying on contour-based visual cues, our strategy focuses on utilizing signal analysis techniques to extract relevant temporal characteristics and spectral frequencies associated with scratch topologies. This shift empowers us to concentrate on the extracted contours themselves and enables exploration of fresh facets related to scratch morphology. Since scratches may exhibit varied orientations, our proposed method employs time-invariant properties to maintain consistency throughout all angles. Specifically, we utilize power spectrum density (PSD) calculation to assess frequency component independently on phase consideration. Deep learning models requires vast amount of laboratory training data, but our method requires less laboratory training data, making it significantly easier to integrate into existing microscopy systems with minimal modification and effort. Potentially, our approach converting new informative features about scratches contours and workflow diagram presented at its slide. Our approach includes few steps. Step number 1 is image processing. And at this stage, we convert RGB images to the grayscale domain. And also, we apply Gaussian filtering to minimize noise and enhance edge detection accuracy. And also, we normalize pixel values at this stage. Step number 2 is binarization or thresholding. We utilize OTSU thresholding techniques to create binary images, because this method automatically can select a threshold level of histogram or grayscale image and binarize it. Steps number 3, 4, and 5 accomplish morphology image processing. We utilize morphology function to remove unwanted pixel from binary image, and also we apply morphological closing operation to fill narrow gaps. Steps number 6 and 7 of our workflow diagram, identification of borders and centroid. We identify the borders and centroid or centers of mass respectively for each object on the image we have. Step number 8 is feature extraction. At this stage, we extract time-invariant features such power spectral density from centroids and border information, unrolled and shifting coordinates from original to our domain. And this slide demonstrates a brief introduction of our results. We can see row number 1, row number 2, and row number 3, respectively. For first one, we can see input images of scratches and surface metal damages. Row number 2 represents identified pseudocolored images where each object, each scratch is identified and centroid and perimeter returned. Row number 3 represent the distances from centroid for each appropriate centroid of each object to the perimeter points. For appropriative classes, column number 1, column number 2, and column number 3, respectively, attrition, line, and scratch. This slide demonstrates power spectral density features extracted from metal surface damages types for appropriative classes, attrition, line, and scratch. This slide demonstrates a 3D principal component analysis representation. The distance minimum, median, and maximum mentioned here between centroid coordinates of clusters in the first 3 principal component analysis domain, reduced space. These measures provide further insight into the distribution of the data set in the reduced dimensional space obtained via PCA transformation. And short conclusion. In this paper, we present a novel approach for the classification of microscopic images of surface scratches through exploratory data analysis, focusing especially in point estimate-based signal analysis instead of traditional image analysis techniques. Thank you for your attention.
Thank you for your report. Dear colleagues, maybe you'll have some questions. Please ask.
I have a question, just a moment.
Please.
Ask. Okay. Well, as I see, your approach involves transitioning from processing object contours in images to a one-dimensional signal, which simplifies the mathematical framework. Can you elaborate, the specific methods you plan to use to process your data in this coordinate space in future research? Thank you.
Yes, you are right. In future research, we plan to further develop the concept of treating scratch contours as signals. This entails exploring additional time domain and spectral domain features, such root mean square as mentioned previously. Such features could be extracted. It could be root mean square and G-peak amplitude, I don't know, crest factor, silence ratio, temporal centroid, log attack time, spectral centroid, spectral roll-off, spectral flux, chroma features, harmonics to noise ratio, and for example, entropy of energy, and much more. By incorporating these features, we aim to enhance the discriminatory power of our classification system and improve its ability to handle a diverse range of scratch patterns and complexities.
Okay, thank you.
Thank you. Thank you.
Thank you. Okay, and next report is a machine learning system for detection malicious traffic generated by IoT devices, authored by Yuri Klotz, Natalia Petlyak, Sergei Martsenko, Vitaly Temushchuk, and Evgen Bondarenko. Are speakers present here?
Yes, present.
Oh, so please, you're welcome.
Can you see my presentation? Can you see my presentation?
No, we can't. Not now. And now? Yes, we can. All's good.
Hello. Machine learning system for detecting malicious traffic generated by IoT devices. By Khmelnytskyi National University and Ternopil Ivan National Technical University. The Internet of Things has broad applications in smart homes, intelligent transportation, and other fields. However, the diversity of hardware functions and communication protocol creates security issues. Reports of IoT devices hacked regularly appear on the Internet. Intrusion detection is important, but requires continuous improvement. Innovation in IoT enhance data management, but also increase the need for security. The diversity of IoT networks complicates security issues, requiring adaptive intrusion detection system to counter this threat in real times. In order to detect prevent IoT attacks, classic system analyze incoming traffic in order to prevent hacking of IoT devices. In network, the IoT works often is possible to connect uncontrolled devices to the internal network. Mobile phones, laptops, and other devices would connect to the internal network are the transport for the malware. Under such conditions, the analysis of incoming traffic does not guarantee the security of IoT devices in the internal network. Therefore, the task of detecting atypical traffic from devices in the internal network is relevant. To ensure the analysis of outgoing traffic, the scheme present on the slide. The traffic analyzer is receive the outgoing traffic, which can help detect specific traffic from infected devices. Analysis of such traffic allow detecting changes in the IoT and reacting to such changes. The conducted analysis show that usually the problem of traffic analysis is solved with the help of machine learning system. The type of analyzed MLS are presented on the slide. Analyzed articles show the recurrent neural network, long short-term memory network, convolutional neural network, and their combination are usually used for traffic analysis. The next slide shows the stage of data preparation for neural network training and testing. They include stages of load datasheet encoding, data normalization, feature selection, and data splitting. And show algorithm for preparation for the CNN LSTM neural network, which includes the stage of dataset preparation, data preprocessing, CNN LSTM, and confusion matrix. This slide presents a neural network architecture that combines CNN and LSTM. This combination allows together the advantages of both neural networks. The next stage was conduct neural network testing on standard traffic sets, his columns of the table. The presented tables show the result of training and testing three neural network architectures on different data sets. The results compared according to the following parameters: accuracy, precision, recall, specificity, and escape. In view of the result on the conductor's research, taking into account the types of attack, the traffic from the implementation of which is present in the analyzed data set, it can be concluded that the CNN-LSTM combination gives the highest reliability result and the lowest error result. Therefore, it is available to use CNN-LSTM and train it on the analyzed data set for detection system of original malicious traffic. In particular, for the VSM-DS dataset, the accuracy of CNN LSTM was 99%. For CIO-2023 dataset, the accuracy was 97%. Therefore, it's advisable to use a combination of CNN LSTM and train it to the analyzed dataset. Thank you.
Thank you very much for your report. Dear colleagues, any questions, please? If any.
I have a question.
You're welcome, please.
Why was the combination of CNN and LSTM networks chosen to IO traffic analysis?
Thank you for your question. A combination of CNN and LSTM network was chosen for your traffic analysis because their unique properties that completed each one. The combination makes them more effective in detecting anomalies and malicious activity compared to using it of this architecture alone.
Thank you. And the second question, why did the paper not consider other data sets for IO traffic analysis?
Thank you for your question. We use the most popular and widely accepted data sets to evaluate cybersecurity models. These data sets have characteristics that make them relevant for IO traffic analysis. They contain attacks and normal traffic. The other data set may not contain the same amount of information or may not be as widely used in the scientific community.
Thank you.
Thank you. Maybe another questions? No questions. So thank you for your report. And let's continue. Next report is regarding graphics tablet and Japan library to detect essential tremor, authored by Ivan Oseychuk, Vitaly Braus, Dmitro Bishchak, Yaroslav Mashtalar, and Ivan Mudrik. Please.
Sorry, 1 second. So, could you see my presentation?
Yes, we are. Please start.
Okay. Dear committee, I would like to present the topic leveraging graphics tablet and JPEN library to detect essential tremors by authors Ivan Oseychuk, Vitaly Braus, Dmitro Bishchak, Yaroslav Mashtalar, and Ivan Mudrik. This study aims to check if the selected system is suitable for diagnosing tremor at a given frequency, considering the challenges associated with its implementation and the obtained data, including the time component. An important part of any study is applicability, and according to statistics, 4% of people 40 and older have essential tremor, and more than 1.2 million are affected by Parkinson's disease. A component of these movement disorders, as well as many others, is tremor. Since tremor has been known to people for a long time, there are certain methods of its diagnosis. These studies focused on the use of the Archimedean spiral drawing test. And previously, paper was used for this test, but using technology has improved its portability and ease. And we use two models of tablets for the experiments, Canvas and Bamboo. An important characteristic of the tablet for the chosen task is the polling rate. Since different types of movement disorders have different tremor frequencies, the digitizer must be able to provide its table to be a diagnostic tool. Besides the tablet, we also need a software layer responsible for acquiring data from the device and saving it in the needed format. The table shows the technologies used to create it. Mostly Java was used to create the motion recording application, and the JPEN library is the system's essential component which allows receiving events from the tablet and interpreting them into languages data structures. Here's a diagram of how the motion recording solution works. A tablet communicates with the operating system through a driver layer. Providers as system-specific APIs are used to communicate with the tablet driver, such as WinTab for Windows. If such driver is unavailable, a standard Java AWT is used, but it has less accuracy and not all types of data. And JPEN connects raw data with the motion capture solution, converting it into Java data structures. The trajectory drawn by a patient is displayed on the screen, and the data from it is saved to a file in specific format. Next, consider the class diagram of the created program. The left side shows mostly the classes responsible for displaying a template and trajectory on the screen. The right side shows the classes for recording the data. As a result, we get the data format shown here, and the absolute time shows the time in milliseconds when the event of pen position changing occurred, since tablet's dependent start time. Registered time shows the same moment, but in the format of the amount of time since the start of the recording. Scheduled time provides information about the moment when the event was sent by the library, and two delta columns store the period between adjacent points. In addition to the coordinates, the tablet may provide information about the tilt or pressure on the pen in time when we use appropriate driver. One of the problems with the data is the repetition of timestamps for different coordinates. An example of such duplication for the scheduled time can be seen in the table. We have different coordinates but the same scheduled time, which is impossible. To understand the picture, we visualized the points obtained for both tablets. The right part shows a significant number of steps representing different coordinates for the same timestamp. On the other hand, the left chart shows a smooth line with each coordinate having a unique time. This pattern is repeated along the entire time axis, but the intensity varies. To analyze this problem, we do such calculation, and in the right table you can see the view of such data in some schematic view. We have unique timestamps and a set of individual points with this timestamp. The left table shows the statistic of the number of such points for each unique registered time value. The data from the WinTab diagnostic tool was also taken for comparison and marked as WT kept in the table. The next one, the left side of this table defines the timestamp group with the corresponding number of different coordinates. For example, time group with 1 coordinate and time group with 4 coordinates and so on. On the right is the number of such groups. As can be seen, all registered points from Bamboo have a unique timestamp. In turn, one unique time point for Canvas is rare, as there is a significant duplication of time values for coordinates. So the frequency is also very important. for this study, and the frequency was calculated based on the first and the last timestamps and the total number of points. This way we can get the frequency that tablets really provide. And we can compare this value with specification of the tablets. The maximum period is obtained as the maximum value from the registered delta columns, which shows time period interval between adjacent points, neighboring points. And in total, 15 experiments were conducted for the Java prototype data and 20 for WT-capped. Both tables shows aggregated statistics for this data with the median taken for each component. In conclusion, the created custom motion capture system provides efficient data retrieval and the ability to customize and pre-process the data. Both tablets can be used to diagnose essential tremor with acceptable accuracy because the frequency, even when duplicated, as for canvas, is higher than that defined for essential tremor, up to 10 Hz. And that's all. Thank you for your attention.
Thank you. Dear colleagues, maybe some questions. No questions. Okay, thank you for your report. And the next report is the modulation of the simulated periodically non-stationary random signal with Hilbert transform, authored by Igor Yavorsky, Roman Yuzefovich, Oleg Lechak, Pavlo Semenu, and Roman Slepko.
Yes, please wait a minute. Do you see us?
Yes, we can, please.
Okay. My name is Oleg Lechak, and I will present our article, The Modulation of a Simulated Periodical and Non-Stationary Random Signal with Hilbert Transform. My two authors are Igor Yavorsky, Roman Yuzefovich, Pavlo Semenu, and Roman Slepko. The modulation procedure of a periodical and non-stationary random signals with carrier harmonics modulated by the stationary high-frequency random processes was explained in our work. Bandpass filtration of signal and Hilbert transform were used for separation of spectral components of periodical non-stationary random signal and quadrature extraction from amplitude phase modulated signal. We also explained the possibility to extract and write estimate the quadratures of narrow-band high-frequency modulation stochastic process. The effectiveness of investigation of the properties of physical systems and processes based on the experimental data of their behavior over time is largely determined by the ability to identify and evaluate their main characteristic features. These features are obviously the repeatability and stochasticity of their behavior, and these features appear in the properties of process for independently but in interaction. Many processes in geophysics, meteorology, radiophysics, signal, and technical mechanics are characterized by this behavior. Periodical and non-stationary random processes are mathematical models describing the complex interaction of repeatability and stochasticity. The methods of analysis of such signals or processes should obviously include in their structure both periodic function and purely stationary random processes. Both
extreme cases, and various models of the interaction of periodicity and stochasticity. Vibration signals acquired in machines and mechanisms during the diagnostics process are one example of such signals and processes. Vibration signal can be modeled as the superposition of harmonics of multiple frequencies, which are stochastically amplitude and phase modulated. Simulation of periodical Anastasia random process signal, as well as its demodulation procedure involving a Hilbert transform, presenting in this article. For simulation of parent path signal, we selected the following harmonical models. Here, W0 is base cyclic frequency, lambda 0 is central frequency of high frequency modulation stochastic process. The quadratures of modulating processes have a following form explained in equation 2 and 3. Now, let us assume the parameters for simulation of ENRP signals. For the simulations, following parameters we use: AP equal 10, AQ equal 4, alpha P equal alpha Q equal to 0.01, omega 0 100 multiplied by P, lambda 0 2000 multiplied by P, and series length was 50,000 points. A fragment of the simulated series and a whole simulated series explained in figure 1. The estimation of the covariance components were calculated using following equations, and they are presented on figure 2. As we can see, the forms of estimators' behavior and their values have insignificant difference from their theoretical values substituted in equation 4, 5, and 6. Now let us obtain the Hilbert transform for simulated PNRP series, and calculations of the estimations of the covariance components based on the Hilbert transform for series confirm that differences between the values of the covariance components for signal and its Hilbert transform are negligible, as we can see on figure 3. The zero spectral component for series was estimated using following equation. Here, K and H is the Hamming window, L and UM is the cutoff point of the correlogram. The spectral dependence graph of F0 shown in figure 4 explain two clear peaks in simulated signal. Now we present Hilbert transform based demodulation method. To separate two spectral components of PNRP signal, we use a bandpass filtering with rectangular transfer function to extract both narrow spectral bands. To obtain a filtered signal can be represented in the form equations 7 and 8. Here, zeta plus and zeta minus are upper and lower frequency bands respectively. The estimators of the autocovariance function for the series in equation 7 and 8 are slowly decaying harmonic oscillations, as it explained on figure 5, the frequencies with central frequencies 950 Hz and 1050 Hz. Obtained estimators values will coincide with theoretical ones calculated with following equations. Now, the values of the second component estimators for the time series in equations 7 and 8 for arbitrary log are smaller than 0.01. Thus, the separated spectral components of 7 and 8 can be considered as realization of stationary random processes. Note that the sum of their autocovariance function is equal to zero covariance components for a signal in equation 4. The cross-covariance functions of signal in 7 and 8 are calculated as follows. We can estimate the second cosine and sine harmonics for the cross-covariance functions of 7 and 8. Adding these quantities, we obtain the estimators of the covariance components in equation 5 and 6, respectively, as it is shown on figure number 2. The Hilbert transform the processes in 7 and 8 are presented the following, and then we can extract their quadratures as using following equations. The segments of the quadrature time series are shown in figure 6. The estimators of the covariance function of the quadrature zeta minus are presented in figure 7. These are slowly decaying functions. Small differences between their values and the theoretical values as it was set during signal simulation, which were determined using following relation, can be explained by statistical errors of calculations. The results of calculation of cross-covariance function shown on figure 8 and 9 confirm that respective quadratures are not correlated. The modulation of the simulated PNRP with Hilbert transform-based procedures proved that it is possible to extract quadratures of modulating processes and estimate their covariance processes with statistically satisfied accuracy. Such processing technology can be useful for the modulation of the complex vibration signals, and that for diagnosis of mechanism. Thank you very much. Do you have any question?
Thank you for your report. Dear colleagues, maybe any questions? Please ask. No questions. So thank you very much for your report. And let's take a short break according to program conference on 20 minutes approximately, and continue after it. Dear colleagues, can you hear me?
Yes, yes. Okay.
Okay, thank you. So let's continue our second workshop, international workshop on computer information technologies in Industry 4.0. And according to schedule, the next is a report on business of AI algorithms for neurocomputer interfaces based on software and hardware technologies, authored by Ivan Stefanishin, Oleg Pastuch, Volodymyr Stefanishin, Igor Baran, and Igor Boyko. Please make your report.
Hello. Do you see my presentation? Everything's okay?
It's okay, please.
Hello, I'm Ivan Stefanishin. Today we will consider the topic robustness of AI algorithms for neurocomputer interfaces based on software and hardware technologies. So this slide represents the content of our presentation. First, we will look at the importance of bionic devices. Then we will proceed to the description of the experiment. Next, we will explain the research process itself, and finally demonstrate the obtained results. So let's move on to the discussion of programs for bionic devices that play an important role in our modern life. So first, bionic devices significantly enhance the mobility and independence of individuals with limb loss, allowing them to perform daily activities with great ease and confidence. Secondly, bionic programs are adaptive learning algorithms to personalize and enhance the functionality of bionic devices over time. So the investigation goal was to use machine learning method to analyze encephalography signals obtained during patient motor activity. Also, we evaluate and compared the robustness of each machine learning method to determine their effectiveness. So we choose a 16-channel computer encephalography complex NeuroCom for the analysis of brain encephalography signals. And for our research, we conducted an experiment in which the encephalograph was worn on a patient to record signals from the brain. During the recording process, the patient performed movement of finger combination. This action allows us to collect all the necessary data for further analysis using machine learning methods. So here, after the experiment, we received several files that with encephalography signals. In the picture, you can see how the received data looks like. Each line in each file represent a recording of encephalography signals at the specific point of time. Mathematical modeling for movement prediction is the use of machine learning method to create model that can predict movement based on input data. This process includes several stages. Model selection. We have to select appropriate machine learning model that is best suited for movement prediction. Next one, model training. Here we use training data to train the machine learning model. And the last one, model evaluation. Here we check the accuracy and robustness of the model to on test data. Okay, let's take a look at the evaluation flow for machine learning method. First of all, we merge all the received encephalography files into a single data set. Then we create an instance of appropriate classifier or machine learning method from the scikit-learn library. After we perform cross-validation by passing the created instance and merged data set, we will add the model on different subset of input data to obtain multiple accuracy for each matrix. Then we calculate dispersion for each matrix based on the obtained accuracy. And finally, we find the models of the vector of dispersion that we calculated. And in the end, we obtain a general dispersion that will characterize the robustness of the mathematical model. So in our research, we use the Python programming language, includes the following packages: pandas, numpy, set pyplot, collection, and skitlearn. And use skitlearn because it is a powerful library that has all the necessary implementation of machine learning methods. We used bagging, boosting, near neighbors, and support vectors classifiers to analyze encephalography data. Each of these files has its own unique features and way of working. Also, we split the dataset 3-to-1, where more of the data is used to train the machine learning method, and less is used to test their performance. As you can see from the picture, the data in each dataset is randomly selected. Let's take a look at the result of the bagging machine learning methods. We obtain the following dispersion result, which you can see on the slide. And here we have this matrix like accuracy of unweighted and row of weighted. Also, we create as a normalization matrix. This matrix gives us a better understanding of the possible classification results and help us to understand how well the model recognizes each class. From this matrix, we can conclude that in general, the accuracy for each class is not the same. We can see that for the classes responsible for the movement of two fingers in the bagging classifier showed a slight lower result compared to the other classes. As you can see. Let's go to the next. Now, let's look at the result of nearest neighbors machine learning methods. We obtain the following results, which you can see in this slide, on the slide. So we additionally format a normalized confusion matrix. From this matrix, we can got similar results as with the previous matrix. We got slight worse accuracy for the movements of two fingers. Next, we will consider the boosting machine learning methods. Here we can see the result on the slide. We also created a normalized confusion matrix. Here we can see the accuracy of each class is very small, in contrast to the previous matrices. And finally, we will consider the support vector machine learning method. We can see the calculation result on the slide. And from the normalized confusion matrix, we can conclude that the accuracy of detecting the movement with one finger is higher than other combinations. And conclusions. After calculation, we obtained the general dispersion for each classifier. From here, we can make the following decision. Nearest neighbors classifier shows the lowest dispersion, which indicates its highest robustness and the lowest spread in measured metrics. This means that it shows more stable and reliable results compared to other classifiers. After that, bagging classifier is the next in terms of robustness, which also shows a fairly low level of dispersion but slightly higher than of the nearest neighbors classifier. However, the difference is very small. Support vector classifier shows slightly higher dispersion, which may indicate less stability in each results compared to the other classifiers. Finally, the boosting classifier shows the highest dispersion, which may indicate the larger spread of the results and the least robustness compared to the other classifiers. Moreover, the accuracy of this classifier in this experiment was extremely low. We recommended using nearest neighbors or bagging classifiers, choosing from these 4 classifiers that we proposed to ensure the best robustness to solving the task of recognizing finger movements for encephalography data signals. And that is all. Thank you for your attention.
Thank you very much for your report. Dear colleagues, maybe you have some questions, please ask.
Okay, Vasily session, please, I want to ask about what is the final goal of application of implemented machine learning model and algorithms?
Okay, we want to create a program which would use encephalograph device to grab data from brain, the signals, and we want to use this data for create maybe some programs for bionic devices for people who has limb lost, and we want to improve some characteristics of bionic devices, and maybe we want to improve their using resources of bionic devices to improve their battery life, and yes, maybe that's all.
Okay, thank you.
Thank you. Any questions? No. Let's move to the next report. Information technology to support the digital transformation of small and medium-sized businesses. Authored by Любомир Мусій, Галина Козбур, Ірина Струтинська, Ольга Мусій, and Vasily Yatsishin. Please make your report.
Oh, can you see my presentation?
Yes, you can, please. You may start.
Dear colleagues, let me introduce the result of the investigation on the topic information technology to support the digital transformation of small and medium-sized businesses. Now, based on the analysis of international programs, policies, frameworks, and online digital maturity platforms, the authors have developed a model for the development of SMEs in Ukraine, figure 1, and the conceptual model of an online platform for expert assessment and analysis of a digital transformation of SMEs in Ukraine, figure 2. The core of the knowledge base is implemented relational database, which consists of 30 tables. Figure 3 shows the main domain entities that have been mapped in the tables at the physics level. Figure 4 shows the part of a relational database responsible for the entity company implementation. This part of the database is oriented towards saving data about the company name and location, fields in which the company works, departments, workers, and workspaces. Table company field details was created to implement relationships many-to-many between table company and company field. Figure 5 shows the part of the database that is responsible for describing the company's digital infrastructure. Now, Figure 6 displays a part of the database that shows the digitalization of workspaces. As shown in Figure 6, this part of the database builds relationships between software, hardware, communication interfaces, and worker spaces. Each workspace will be evaluated by experts in the future. Figure 7 shows a part of the database that displays data to support the process of expert assessment. The created database is used for the presentation data, which will be sent to the recommendation service or recommender engine. Recommendation service works using the technology of collaborative filtering. Figure 8 shows other approaches that can be used to implement a recommendation system. The main idea of using collaborative filtering technology is the preparation of a cross-tabulation matrix where column interpreter interprets the questions and rows display the company's name. In the cells of such matrix will be expert assessments as quantitative values of answers for each question in the interval from 1 to 5. Figure 9 shows the structure of the cross-tabulation matrix, and in table 4, the scale which used in the expert evaluation process. The main idea of using collaborative filtering in the process of making recommendations is to improve the level of company digitalization. In case the company has no digitalization, the system can make recommendations based on the most popular digital solution implemented in the companies of the same working area. It's a cold start of digitalization that can be described by Formula 1. In case when the company has expert assessment for some or all characteristics and wants to improve its level of digitalization, it's possible to use Formula 2. Similarity measure of level digitalization uses different evaluation metrics. The two most popular metrics are the cosine metric and Pearson's correlation metric. Cosine matrix is calculated by Formula 3. Formula 4 is a metric that gives more accurate results than the classic cosine metric. It takes into account not only positive values and zero, but also negative values in the cross-tabulation matrix. Conclusion. This expert system structure ensures the collection and analysis of data on the digital transformation of SMEs, the application of expert knowledge and AI to access and provide recommendations, as well as continuous training and adaptation on the system. We propose and plan to use a deep learning approach for making recommendations and improving expert assessment, but it will be in the next articles because first we need to gather enough data about companies with different levels of digitalization. At this stage, our system is oriented towards receiving data about companies' digital infrastructure and allows making expert assessment. Collaborative filtering is a static approach that helps us to automate the process of building recommendations for companies when there is not much data. Thanks for attention.
Good day. I have a question for us.
Please.
Thank you. Why did you choose relation database or saving data about level of digitalization and not, for example, MongoDB or other NoSQL database?
Yes. We have chosen relational database because the first, more than 80% of databases are relations databases which developed a flexible mathematical background and signature. The second, when we build a cross-tabulation matrix, it's more convenient to make filtering of necessary data from a relational database.
Oh, thank you.
Thank you.
Thank you. Maybe another questions? Okay. Next speaker sent me a message that he had a power outage. So he can't present his paper now. So his paper will be the last at the end of this session. And now I would like to give a floor to our colleagues from China. I see they are present here. And to report their paper on generative AI and its impact on labor productivity. Oh, I'm sorry, critical flow rerouting based on policy gradient algorithm. So please, can you present your paper? Dear colleagues from China, can you present your papers? Maybe here are present authors of paper critical flow rerouting based on policy gradient algorithm. Can you present your paper? Dear colleagues, course contrastive recommendation algorithm based on hypergraph convolution. Can you present your paper? Dear colleagues, Kyung-hee, critical flow rerouting based on policy gradient algorithm. Can you present your paper, please? Or please write, maybe you have some technical problems. Please, we are waiting for your presentation. Okay. Okay, I'll try. So next presentation is course contrastive recommendation algorithm based on hypergraph convolution. Maybe presenters are present here, please. Our Chinese colleagues has technical problems, so we'll wait a few minutes.
Hello, do you hear me?
Yes, we are. Please, can you present your report?
Could I show you the video of our presentation?
Oh, yes, we can see your report. Yes, okay, please, you may start.
Basic gradient algorithm. With the rigorous development of internet technology and the continuous expansion of network scale, data center has become an integral of net infrastructure. However, the growth of data center scale has also brought the problem of exponential growth in data traffic within data center networks. The aggregation of massive network traffic has made the data center network management quite complex, leading to a lot of impact on overall network performance. Therefore, it has become a pressing challenge for current data center network to reduce network congestion probability, achieve load balance of network links, and improve data center network performance while maintaining constant transmission latency. The goal of network routing optimization is to control the distribution of traffic by configuring routing on the network topology, thereby helping internet service providers optimize network performance and resource utilization. Net routing optimization algorithms can be broadly categorized into three types: flow level, and package network routing algorithms. Among them, flow-level routing algorithms treat packets with the same source and destination address as a data flow, which can also be defined based on the specific scenario. Compared to package-net network and flow-net network routing algorithms, flow-level routing algorithms have a closer granularity, but can avoid issues such as packet misordering and difficulty in flow-net partitions. Existing routing optimization algorithms are mainly based on flow-level routing, which achieves node balancing on each link by periodically rerouting all flow in the network topology, thereby reducing network congestion. Although rerouting all flows in the network topology can achieve near optimal network performance, it imposes a heavy computational burden on the SDN controller, which may cause serial network interface or service interruptions, leading to a significant impact on user experience. Therefore, network operators are reluctant to adopt these existing routing optimization algorithms when deploying networks. And there is an urgent need to design a rerouting optimization algorithms that can achieve node balancing while reducing the routing computational burden and the network interference. To address the conventional problem, this section presents a key flow rerouting optimization algorithm called CITI, which is based on heuristic gradient. This algorithm does not rely on many domains to clearly instead optimize the heuristic gradient algorithm to learn a key flow rerouting tree. The network performance serves as a reward signal that feedback to participating, allowing the AD to gradually learn better network performance by continuously overloading the actual performance of past collisions. The CIRPG algorithm optimizes its routing strategy for various traffic metrics over time. Once trained, the CIRPG algorithm efficiently and effectively select a small set of key flows that have a significant impact on network performance for daily traffic metrics. By rerouting these key flows, it prevents the need optimization in the network and achieves optimization of network performance. As shown in Figure 1, this is the architecture diagram of the CIRPG algorithm designed in this section, which can include 5 components. SCN is the network environment, state space agent, reward function, and action. sets 3 multiply 3 and a stripe of 1. The second layer is a fully connected layer with 128 neurons. The activation function used in the first 2 layers are making ILU and ILU respectively. The final layer is a linear, fully connected layer with neurons, where corresponds to all possible creative flow. The softmax function is applied to the output of the final layer to generate the probability of all available actions. The experiment was conducted on the Ubuntu operation system using the MiniNet network simulation platform to build the dataset network. The open source RYU controllers were employed as a controller for the entire network. MiniNet is a nice with network simulation platform that comes with built-in switches supporting the open flow protocol. Using Python command, a complete network couplet can be constructed in MiniNet, and the code developed on this platform can be easily transferred to real network composed of physical hardware. RYU is currently one of the most popular open source SDN controllers, providing rich APIs for centralized network management and simplifying network administration. The CFRPG algorithm was implemented in Python using the TensorFlow framework and deployed on RYU controller. The specific experiment of 4-tail fat tree topology architectures was analyzed in the experiment as shown in this figure. This topology consists of a core layer, aggregation layer, and an edge layer with a total of 16 terminals hosts and 20 switches. Each switch supports the OpenFlow protocol, and the link transmission between nodes is set to full duplex to enable bidirectional data transfer and ensure reliable and stable transmission. Additionally, to ensure network performance and stability, the bandwidth of each link was set to 10 Mbps to meet the requirements of the experiment. By fixing the parameter other than the number of critical flows, this study investigates the impact of K on load balancing in SDN data center networks to determine its optimal value. These figures illustrate the load balancing achieved by CFRPG algorithm with varying numbers of critical flows K and the 2 traffic patterns. This figure illustrates the comparison of node balancing index among ECMP, ELP, and CFRPG algorithms and the 2 traffic patterns as the sending bandwidth varies. From the graph, it can be observed that CFRPG algorithm achieves a significantly lower load balancing index compared to DLP and the ECMP algorithms. The load balancing performance of DLP algorithm is slightly better than that of ECMP algorithm. The reason behind this is that ECMP algorithm only evenly distributed the traffic across the link without considering the network's overall state information and the magnitude of traffic load. This can lead to network congestion, resulting in the highest load balancing index and the poorest load balancing performance. So that's all. Thank you for listening.
Thank you very much for your report, dear colleagues. Maybe you'll have some questions. Any questions? Okay, so if now the next report is coarse contrastive recommendation algorithm based on a hypergraph convolution. Please write our presenters here. Nobody, but I have a message, and I would like to give a floor for our Chinese colleagues and present their paper, Optimal Control Scheme for Signalized Intersection based on phase stream combination in autonomous driving environment. So please, if you are ready, you may make your report.
Hello, Chair. Hello, Chair.
Yes,
For cost contrastive recommendation algorithm based on hypergraph convolution, the author has asked the committee to change the program to tomorrow.
Okay.
Yeah.
Okay. We'll be waiting this report tomorrow. And the report on optimal control scheme for signalized intersection based on phase stream combination in autonomous driving environment. Other speakers present here, may you present your report? Okay, we can see your presentation. Please, you may make your report. I'm sorry, but we can't hear you. We can see your presentation, but can't hear you.
Can you hear me?
Yes, and now we can hear you.
Oh,
Please.
okay. I repeat it. Now I will introduce my paper, optimal control scheme for simulated intersection based on phase stream combination in autonomous driving environment. Currently, research on intersection control in the autonomous driving environment focuses on vehicle-to-vehicle information transmission and real-time optimization of intersection control timing schemes by accurately collecting inbound traffic flow parameters using advanced autonomous driving technology, but does not consider the compatibility of refined streamlines. Therefore, our research team has developed a more comprehensive algorithm for determining signalized intersection phase stream combinations taking into account the compatibility between cross flow, divorcing flow, and merging flow to validate the effectiveness and the compatibility of the new algorithm. This paper compares the new scheme with the RBS phase combination scheme, divergence phase combination scheme, and the combination phase combination scheme using exciting timing models. The feasibility of the new scheme is verified, and the optimal intersection control scheme is further derived. The algorithm takes into account the compatibility of conflicting, diverging, and merging relationships among the flow streams, specifically refining the merging relationships previously identified as conflicts into compatible relationships in the context of automated driving environments. Next, all stream combinations and evaluated based on the requirement, and that phase stream combinations must be compatible, and the considerations such as line conditions for streamline settings in order to identify all feasible phase stream combinations. Subsequently, the phase combination control scheme, which includes all intersection streams and the continuity of successive moments within the cycle, is used as filtering condition to derive variable phase stream combination schemes at a current stage. Numerous signal timing models are available for determining phase combinations, with HCM 2010 timing model being one of the more conventional options. To validate the effectiveness of the paper's algorithm, verification analysis is conducted using the specific example, assuming that at the intersection, right turn lines are all equipped with exclusive right turn lines using channelization extends. The right turn streams are not controlled by since the specific line configuration and corresponding samples for the streams are represented as shown in Figure 1. According to the method of determining phase streamline combinations, all size of phase streamline combinations can be calculated, but they are not listed one by one due to the large number of elements after determining the phase streamline combination. It is necessary to determine the phase combination scheme through calculation. It is known that there are 109,200 sites of all phase combination schemes. There are a total of 400 sites of feasible phase combination schemes that meet the conditions determined through programming, including 48 sets of full phase combination schemes, 216 for size of 5-phase combination schemes and 88 size of 6-phase combination schemes as shown in Table 1. The traffic flow at the intersection reaches random nature, and in the autonomous driving environment, the traffic flow of each line at the intersection can be directly obtained through wireless communication technology. That's assuming a set of random traffic flows for each line at the intersection as shown in Table 2. By calculation, the average delay of vehicles corresponding to all feasible phase combination schemes is shown in Figure 2. Average delay of value of the minimum streamline vehicle in the figure is 79.3 SPTCO, where the maximum value is 173.03 SPCO, which is more than twice the difference between the two. This indicates that the phase combination scheme has a significant effect on intersection control, and selecting a reasonable phase combination scheme is very important. Furthermore, through calculation, it was found that there are 4-phase combination schemes corresponding to the minimum average vehicle delay. Number 316, 329, 360, and 373. When selecting the intersection signal phase combination scheme, any phase combination scheme can be chosen as a actual adopted scheme. The corresponding phase combination schemes are this. By using the phase combination scheme corresponding to the number 316 as the optimal control scheme for the intersection, and comparing it with the conventional phase combination scheme, it is evident that the algorithm proposed in the paper can further reduce vehicle delay at the intersection. We input the calculated conventional signal control scheme and the corresponding timing scheme of the PM scheme into the simulation software. The specific simulation comparison results are shown in Figure 3. The simulation results show the phase combination scheme obtained by the algorithm in the paper has achieved varying degrees of improvement in the various simulation indicators compared to the other schemes. By combining exciting timing models, calculate the true optimal control scheme for intersections through numerical examples and simulation analysis. It was found that the algorithm can further reduce the average delay of vehicles on the intersection flow line and improve the efficiency of intersection control. That's all. Thanks.
Thank you for your report. Thank you very much. Dear colleagues, maybe you have some questions. Please ask. No questions. Dear colleagues, are there any speakers who would like to present their papers today? Okay, so the last report is phased anti-spoofing system optimal threshold selection criteria. But because of power outage, speaker Ostap Stets can't be present here and can't present his paper, but we have a video presentation of this work. So I'll turn on it.
Dear colleagues, we bring to your attention an article on topic of optimal threshold selection criteria for phase anti-spoofing systems. To begin with, biometric identification systems are now really common, providing convenience but also posing new challenges. The rise of automated biometric systems like face recognition has increased the potential for presentation attacks, further PAs. Face anti-spoofing is essential in combating these attacks, ensuring the integrity of biometric security systems. This technology is crucial in various high-security domains where facial recognition is vital for authentication and access control. Security-sensitive areas face greater risks from a range of attacks, including videos, photos from mobile phones, both printed, masks and morphing techniques that blend images to create fake identities, for example using other artificial intelligence tools. These sophisticated attacks demand robust countermeasures for secure and reliable identification processes. In less security-intensive environments like social media and online shopping, the focus of presentation attack detection (PAD) shifts towards balancing security with user experience. The challenge in these less critical areas is to minimize user friction while maintaining effective security until PAD solutions are perfected. Our article is devoted to the problem of error threshold selection. Considering that there is no currently face anti-spoofing system which is completely error-prone, it's really necessary to carefully select those error thresholds. For example, if we set high thresholds, it can cause user frustration and potential abandonment of the biometric authentication process when it's not critical. On the other side, if we set low thresholds, it implies security risks by potentially allowing unauthorized access. To describe how presentation attack detection subsystem works, we could break the whole process into 3 simplified steps. First one is data handling, where the biometric data from face recognition system is analyzed by the PAD subsystem using a convolution neural network. Then the PAD subsystem outputs a confidence score indicating whether the data is genuine or fraudulent. And lastly, the decisions are based on comparing the confidence score against a classification threshold guided by standards such as ISO or IAC. PAD systems are evaluated by key performance metrics such as APCR, which stands for Attack Presentation Classification Error Rate. It measures the rate at which attack presentations are incorrectly classified as genuine. and BPCR, which stands for Bona Fide Presentation Classification Error Rate. It measures the rate at which genuine presentations are incorrectly classified as spoofed. Here are the formulas to calculate these metrics. It is important to know that APCR metric considers the number of attack presentations for a given presentation attack instrument species. Also, we include here another metric, which is ACER, which is basically the average between APCR and BPCR. As the outcome of the PAD system purpose, attack presentations tend to receive lower scores while bona fide presentations receive higher scores. However, because these scores overlap in most cases, a specific classification threshold should be selected. On this histogram, an average PAD system scores are displayed, and as we can see, there is no way to skip setting a threshold which causes APCR and BPCR to overlap other scores. There are several known ways to set the classification threshold. The most popular and simple one is to set classification threshold by minimizing equal error rate, equalizing APCR and BPCR using training dataset. The downside of this approach is ignoration of the PAD operational environment as well as security requirements. Then what can be done? Experimentally adjust classification threshold based on system requirements. The downside of this approach is the need for manual processing of relevant classification data. And the third approach is to use RIA-PAR metric proposed in 2023 revision of the standards which define the metrics for PAD systems. It is used to measure how well a biometric systems detect attacks without interrupting legitimate users. This metric places user experience and convenience higher in the process of selection optimal threshold, making it barely suitable for security critical areas. Here is the formula to calculate this metric. To mitigate this problem, we could implement an optimal threshold selection formula which could allow us to automate the process. As you can see, we are implementing the environmental adjustment, which is a factor that accounts for variations in environmental conditions that may impact the performance of face anti-spoofing system. It can be expressed as a function of environmental parameters such as general security conditions and requirements, for example, availability of human intervention to the identification process, biometric presentation specific conditions, and other PAD product specific criteria. And you can see the formula to describe the environmental adjustment. As you can see, it has the weight assigned to each environmental factor based on its importance and the impact on the system's performance, as well as the value of the environmental factor, which could be positive or negative at the given moment, considering how it is supposed to impact the general threshold. To conclude, our research examines the selection of optimal threshold in face anti-spoofing systems to enhance security and maintain user convenience. We have found that traditional approaches focus on minimizing equal error rates, often overlooking the variability in operational environments and security needs. Most production-ready PAD systems adhere to the ISO IEC standards, utilizing metrics such as APCR, BPCR, and ACR to assess performance. But the diversity and the number of spoofing tools make it hard to model all the potential spoofing methods, complicating the fine-tuning of the PAD systems. We have analyzed systems like ABC4EU and highlighted the shortcomings of the static threshold settings based on the pre-trained datasets. We have introduced a method for automated threshold selection with an environmental adjustments factor, which consider the deployment context-specific security and user experience needs. This enables us to dynamically adjust thresholds based on environmental parameters allowing face anti-spoofing systems to operate more effectively and securely in various real-world settings. Thank you for your attention.
Dear colleagues, all the reports scheduled for today have been presented. On behalf of all the workshop organizers, I want to thank you for great work done. This concludes the work of the first day of the workshop. Tomorrow we will continue the work of this workshop. It will be the second day. So have a great day, everyone, and stay safe. Goodbye. Thank you for your presentations.